Good morning, everyone. My name is Allison Trumbull, and I am an account executive here at Automation Alley. Thank you for tuning in to our Tech Takeover series this morning. We've been seeing a lot of changes and uncertainty the last few weeks, and we are so happy to be able to provide content that will help individuals and companies return to work successfully and start or continue your digital transformation. So if you're not familiar with Automation Alley, we are the World Economic Forum's Advanced Manufacturing Hub, or AMHUB, for North America, and we are Michigan's Industry 4.0 Knowledge Center. Our mission is to help educate our members on the rapid technological changes taking place within the industry, focusing on digital transformation, branding, and telling your Industry 4.0 story. We do this by hosting a series of information-packed events throughout the year, both in person and, as you can see, digitally. We host these Industry 4.0 focus sessions every Wednesday. Our Tech Takeovers, either in person or via live stream. Be sure to check our website for past Tech Takeover recordings, as well as today's presentation will be on the website after this morning as well. And beginning July 13th, we will be debuting Automation Alley's 2020 Technology and Industry Report, titled Industry 4.0 Focus. This will launch a live stream series featuring Automation Alley's Executive Director and CEO, Tom Kelly, and the report's key contributors. So that'll be sponsors, case studies, universities, as they break down the report's emerging technology trends and action items for industry. So these will be 1-hour live stream interviews with our CEO, Tom Kelly, on our website. So be sure to register for those today. And lastly, Automation Alley does have our Integrate conference coming up in November. So that's going to be at TCF Center in Detroit, in-person conference, all 2 days, all about Industry 4.0. Breakout session, expo tables, round tables, all of it. So be sure to reach out to me if you have any questions, or you can always find information on our website. All right, and lastly, I would like to say an introduction to Justin today, who's going to give our presentation from Ascent Aerospace. He is the Global Product Manager, Drilling and Fastening Technologies at Ascent. If you're not familiar with Ascent Aerospace, they are the leading provider of aerospace tooling systems, factory automation, and integration solutions. So this morning, Justin's going to be talking to us about the unique manufacturing challenges of large structures, from automobiles to aircraft, and how these challenges present opportunities for the development and application of new technologies. He's going to be diving specifically into how to identify the right size robotic solutions for the right size applications. So thank you so much for joining us today, Justin. The floor is yours.
Excellent. Thank you, Allison. Much appreciated. And good morning to everybody that is online this morning to join us as we kind of walk through this presentation. Just give me 1 second here to get the presentation started up. And then we'll go ahead and get started. All right, so welcome everybody to Ascent Aerospace's presentation on flexible robotic solutions, focusing on identifying the right size solution for the right size application. Just a quick overview of what we'll be going through is a quick introduction of the overall topic, and then we'll focus on a key element overview, and then we'll follow up with going through the key elements in a little bit more detail, as well as sharing some examples and case studies to support the various elements and maybe provide a little bit more perspective on exactly the various steps that you would go through as you work through this process. And then finally, we'll kind of wrap up with some known methods for robotic solution selection. So just a quick recap of what Allison kind of went over. Manufacturing large structures definitely has its fair share of unique challenges. And in working through each of these in a collaborative manner, there's a lot of opportunity to identify new technology, new ways to handle things. But then there's also advantages to taking a step back and figuring out if there's maybe a chance to repurpose or reevaluate old methods, but maybe brush them off a little bit in order to provide for you a new way of attacking a problem. So an old solution, but applied in a new way. So you don't necessarily always have to reinvent the wheel. That you can kind of work through it in a way with some traditional ideas as well. And so this specific presentation, what we'd like to do is focus on the key elements necessary for this collaborative effort to achieve the right size solution for the right size application. And as Allison had mentioned right at the beginning, just a quick introduction to myself. I am the Global Product Manager for Drilling and Fastening Technologies for Ascent Aerospace. I've been working in automated industries for the last 20 years or so, both on the design as well as the integration aspect of the job. So from kind of inception to final buy-off for various projects. I've had an opportunity to work in both the automotive as well as the aerospace sectors. I do have a bachelor's in mechanical engineering from Kettering University, formerly GMI, as well as a master's in mechanical engineering from Lawrence Tech and a PMP certification from the Program Management Institute. But enough about me. We'll get into the actual key elements now for the right size solution for the right size application. So there's a series of elements that you are going to want to focus on as you go through this specific process. And first and foremost in all of this, we're going to highlight each of the pieces in short detail, and then we'll expand on all of them as we get further into the presentation. So the first one that we're going to want to talk about is application. And this is really the key one that sets the tone for the rest of the areas that you're going to need to focus on as you and your team walk through the overall this overall process. What do you want to automate? What solution are you looking for? What problems are you trying to solve? And then as you go through and talk with your team, then you get to the next level of understanding and information in terms of, now that I know what I would like to go do, what are my available options? What technology is out there? What's traditional? What's viewed as cutting edge? And then where does the risk lie in how you want to apply those various options? And then you get to the next part. Once you get your wish list all put together, now you get to the part where you say, what can I actually afford, right? There's a lot that goes into that, and in terms of consideration. And so just being able to map that out and do an apples to apples comparison can really give you that overall perspective, and as well as sell it to your management team that you have in fact identified the right solution, and you're not going to break the budget as you move on to the next steps in the approval process or execution. Then from there, you'll get more into specific details such as the various processes that you have available and what you're trying to accomplish with the automation, environment characteristics, things that you need to be specifically cognizant of, what you're bringing into your whether it's a manufacturing facility or building, and then obviously space allocation. How much room, how much size do I have in terms of being able to bring this solution into the place? Sometimes it has to be small and compact. Other times it can be large. Just kind of depends on what you have at your disposal. And then when you get down through all of those pieces, then you get into, okay, now that you know how much space that you have, what are your scalability requirements? How flexible does this need to be? Is it kind of a one-fit solution? Does it have to be able to address many processes or many challenges? And then that kind of segues into the nuts and bolts of the consideration, which is things such as payload and reach and accuracy. And so as you kind of step through from left to right, with all of your key stakeholders and put together this whole story, then you kind of get to the part where you've identified that right size solution for your application. But that being said, before we go any further, one of the key things and challenges that you're going to face right at the beginning is to be able to get everybody to remove the preconceived notions about the costs and complexities of robotics and then be able to apply more of an impartial, a systematic approach to answering these questions to find the business, to identify the solution that your business can utilize to solve the challenges that you have each and every day. So going into a little bit more specifically on the first item, which is application. So again, what application what's your overall automation goal? More importantly, what problem or problems are you trying to solve? You may be faced with a series of questions or maybe just one question from your senior management team. Hold on one second. Looks like we've got an issue with the PowerPoint. One second here. Is that any better? Sorry for the delay. Oh. Now it's all kinds of goofed up. How's that? Let's see here.
You got it.
Is it working now?
Yep, it's all good now.
Perfect. All right, good deal. Sorry about that. All right, so the next part here is specific questions that you as a team might encounter related to the application and the problems. Maybe there's a mandate to increase output. There's a need for an improvement in quality. Maybe the team is struggling for finding someone to be able to fill those repetitive task, manual type jobs, or there's an element of danger in terms of process where there's workers' health and safety that needs to be evaluated and potentially addressed. Overextending, growth without overextending workforce, or being able to react to fast-changing products. Some level of variety along the way, and making sure that you kind of capture all of these various answers. And this is important because this is really the topic that, as a team, you're going to spend the majority of your time. The better you outline this and answer these questions, the way more easier the process is going to be to get through the next steps, because then it becomes much more direct in terms of the solution that you're trying to achieve, the budget that you're going to need to go get it approved, and then the implementation process for making it happen. And obviously, as we all know, when you're trying to sell stuff like this, the more well-rounded that case can be when you take it to the management team, the faster you will be able to get an answer to that specific budget and question, if you're able to move on to the next steps. So then once you get past that gate, that kind of gauntlet of discussion, then you get into the part of, okay, now that I know what problem or problems I'm trying to solve, what are my options? And this is the part where it starts to get a little bit overwhelming, because as you see, you're going to get hit with a lot of different options when you dive into the Google searches, and you're going to find words like industrial, SCARA, Delta, medical, service, articulated, collaborative, gantry, and you're going to say, what does all of this mean? Well, here's a few pictures that kind of give you a little bit of an overview of exactly what you're talking about and what you would find as you start working your way through the solution. You have things that are gantry and industrial, which are definitely your heavy hitters, your big pieces of equipment that are kind of a move and get out of the way and let me do the job because of the environment or the processes that you're asking them to take care of. or you can have things along the lines of a SCARA or a Delta, or even an articulated and collaborative robot where you're actually working in close proximity to people. Maybe you have technicians that are around the area, and that way you need to make sure that the technology matches the safety for the environment and yet still gives you the solution that you're looking for. But at least kind of knowing the full range of the options, it allows you to look and investigate in each one of these and really pick what matters to you most from a solution standpoint. Expanding on that a little bit further is, in addition to the various options for the robotic motion, you have a variety of process options to choose from, right? Maybe you're looking for a single small compact end effector or process head that just drills holes all day long, and that's exactly what you need it to do, because that's what gives you the best quality and return on investment. Or maybe you need something that is a little more complicated and has multi-function capabilities, because you have a series of processes that you need to address, but you don't really have a lot of room to have multiple stations, so you try to keep it as consolidated as possible. Maybe you have an application that requires not only mobile flexibility to be able to move around the different parts of the plant, but you also need a solution that can do drilling as well as machining. So like what you see here, a parallel kinematic machine on a mobile platform is best suited for your application, because it gives you some flexibility plus the necessary horsepower to address your different process needs. Or maybe you just need an entire station's worth of equipment. You've got things that are big and heavy and hard to move, so by loading your specific parts into a station, then you let the rest of the automation do all of the moves and manipulation, as well as the processes such as drilling and fastener installation, in order to complete the work, complete the subassembly, and then allow for one overhead crane move to move the piece out of the station and move on to the next step in the overall process. Now, once you get through all of that and you kind of get dialed in for that part, then what you can't forget about is there's also some auxiliary options that come along with this. If you're going to have a feed, such as fasteners that are needed for your process, chances are you're going to need some form of a feeder system. So then you get into whether it is a vibratory bowl or a cassette feeder system, something else that needs to be accounted for in the overall budget and as well as the footprint, but is also going to give you the best return for supporting your overall workload. Maybe you have something that's a little more messy, such as a sealant application. Obviously, applying sealant is very time-consuming and kind of a work of art, but applying an automation process to simplify that definitely improves your overall quality. Maybe you have big things, big components that you're just trying to move from one location to another. So having something like a material handling system that works either in conjunction with the rest or just supports that heavy motion is in line with what you're going to need. Or maybe you just want to have something that is better than your everyday 9 to 5 inspection from a quality standpoint. Something that can learn as it goes, as well as improve the overall spotting of any defects, and make sure that your output to your customer is as reliable as possible, and being able to address those items ahead of delivery and having to take those items back as you go through day-to-day operations. Then the next part here, moving into the next category, is after you've gone through those two major gates, is what is the robotic solution and how is it affordable, right? So the key thing here is it's definitely more involved than just the pros and cons list if you're really trying to make the overall sale to your management team. At first, you look at the list that's on the left-hand side, and you can see, man, there's a lot of different categories that need to have some dollars attached to it, such as design, commercial items, fabrication, integration, as well as facility updates. And that could add up to a pretty big number when you get through, going through all of the different categories for a robotic solution. It's a little bit less intense when you talk about a collaborative robotic solution, because the size is not the same and there's a little bit more flexibility there in that regard. But when you get down to the comparison, there's a certain level of detail that you're also going to want to have mapped out, with the help of your different teams, such as HR, from understanding, your worker salary, your benefits, money spent on training, money spent impacted by downtime and overtime, and product scrap. So when you get down to it, there's a very good chance that the robotic solution could be, as much or even more expensive with the various processes that you're trying to either replace or supplement. But cost is not always the primary driver in a decision like this. There can be very much a case made more often than not that this type of flexible solution, even though its initial costs are equal to or greater than your manual processes, if the recurring costs generated are lower, your overall output is greater and the quality is improved, there's still a very good selling point here. And if the more detail that you can provide for exactly what's all been accounted for, yes, it's affordable, yes, this feeds into the consideration for your return on investment, this gives you your best leg up when pitching these types of ideas to your management team. So now we'll take a half step into processes here, because overall, you're not always looking for something to do everything for you in terms of your solution. Sometimes you're looking for something along these lines where you have a person that is installing rivets in the side of an airframe and does it for many hours a day, and that is it's a high impact. So there's a lot of difficulties and challenges that come with doing this level of repetitive work. So maybe you have a robotic solution that's a little bit smaller that can work alongside the worker, or you've got the heavy-duty robotic drilling solution that just does all of it all in in a single process. Another example here is fasteners. As you can see on the top, there's a bag of fasteners that would usually be carried by someone from station to station. Some of them are pretty small. You have to obviously retrieve them from a bag. You have to orient them in the right way and do the actual installation. Or you could go as far as having them loaded into a cassette or a vibratory bowl and let that equipment do that alignment. So there's still a process for bringing the right pieces to the automation. There's still an overall quality control method that is required by technicians and operators, but you get a chance to have equipment work alongside of them to make sure that the parts get delivered to the station in the correct orientation and saving overall time for the manufacturing side. Sealant is another tricky one in the industry. Doing sealant by hand is still a thing. It's still a method. Not everything from a sealant application can be automated. Challenges of the different styles of sealant, specifically aircraft sealant, have quite a few challenges from a shelf life standpoint. So there's usually a need to do it by hand. But if you could find a way to pair it with a robotic solution, then you give that chance of overall quality improvement and ideally a cycle time improvement as well, which would help your overall manufacturing process. And then maybe here you have multiple processes that you're trying to automate, and you got a little bit more floor space to work with. So something along these lines where you have a series of manual stations within a local overhead gantry system to bring the pre-worked panels into an automation station, let them do some of the work, and then take them to inspection stations. So you have this combination of the manual work along with the automation to support your overall manufacturing processes. I'm going to touch on our first case study here now. This was a front spar and D-nose drilling solution. So you can see from the pictures that what's on the top picture was a tool and the engineering that was already being worked manually all the way up until 2016. And what was happening is their overall time was significantly long because all of the drilling that was taking place on these contoured surfaces was being done by hand. So there was a certain amount of setup time as well as layout of the holes by hand, and they had come to a conclusion that was just taking up too much time, and there's definitely degradation of quality as they got through the number of ship sets that they needed to produce as rate was increasing. So they came to a conclusion that they wanted to invest in an automated solution, and the solution that was presented was an arc frame drilling system that allows for 360 degrees of part access, 220 degrees of travel, and the highest quality to do an INR hole pattern, which is interchangeability and replaceability. So they didn't want to have to go back and have to re-drill holes. They wanted to take pre-manufactured panels and have the whole quality be so good that you could just take one panel off that was damaged and put another one on and not have to worry about reworking any of the holes. So working in a collaborative effort with this customer, we were able to add the automation to an existing system, an existing tooling system, as well as put together the part programming necessary for the driller to do all of the heavy lifting of the drilling work, and then allowed the workers to focus on more the quality, the inspection, the buy-off of the components and of the sub-assemblies, and then moving them into their final assembly stage. Second case study here related to process was even more in depth, where as a team we had to start essentially from a 35-year in the making manual process, and work with the customer to not only lay out what all of those new process steps would look like, because doing it in conjunction with automation made them very apprehensive. So before we even got to the design part, we went through a series of engineering processes, designs, and simulations at the CAD level, and then started to implement what they felt were the best pieces of technology, adding a robotic pick and place for the size and the weight of the panels that they needed to move around, smart tooling that worked in conjunction with the robots, so there was a lot of coordinated motion that was also required, so all of the pieces had to talk to each other in an efficient manner, as well as in-station welding and X-ray inspection. And the X-ray inspection was really one of the biggest time savers, because traditionally this piece of engineering would have to leave the station, go to an X-ray booth, come back after the results were processed. So it ate up a lot of cycle time and overall span time for the station. So being able to do it in parallel to the remaining processes has definitely brought the customer down considerably for the amount of time it takes to get through this. So it was a very good collaborative effort, and something very, very, very much so that both teams were proud of that they were able to achieve. Moving on to the environment aspect of this, one of the key things is it safe? Is it a safe and desirable place for a human to create a high quality product? And unfortunately, we still have areas where that answer is no. In this particular case, you can see here that you've got a robotic solution that's lifting a very heavy billet. Normally would be done by a person, and it's not only is it big and heavy, it's also, it doesn't have a lot of good grip surface. So being able to assist in the process by adding a robotic for the material handling aspect was definitely the right way to go in terms of their manufacturing process and their solutions. Welding, especially welding of cars, car structures, it's a very dense, heavy workload, very high cycle time, very high demand. So being able to do something like this manually in order to produce the right level of automobiles for supply and demand, it is not good. It's not the right place. So being able to work through these challenges and apply automation in this respect gives each OEM the advantage of maintaining the rate while keeping workers safe and out of harm's way in the heavy work area of the environment. And then the last one here, just to kind of touch on it, this is a very tall final assembly structure for a wing assembly. Now, traditionally, you would have 20 workers on various levels of platforms and gantry and scaffolding, drilling thousands of holes all day long, climbing over each other as well as climbing onto the product. And it wasn't a sustainable way for them to maintain the rate for the product that they needed to provide to their aircraft manufacturer. So being able to add a tall gantry drilling system allowed them to bring back the operators, train them more into how to use the equipment and focusing on the quality and the inspection of the final product and making it a more collaborative effort in that respect. One more case study here real quick. We had an opportunity to do a wing skin lift and rollover fixture back in 2017. You can see from the details, it was 85 feet by 150 feet. This was a very long wing skin structure, as well as had multiple variations of it, 8 different panel configurations, and it needed to go from a horizontal condition and be raised up into a vertical condition. Traditionally, this was done by overhead cranes, multiple people with taglines trying to hold on to this wing skin and make sure that it did not move in a way that would be unsafe. It was a very stressful, very cumbersome process that slowed them down considerably. So they came to us with the idea of being able to do this in an automated fashion, and despite the size of it, it was a very successful project in being able to load the different variants of skin panel as well as raise and lower while keeping everybody a safe distance away from the product. So taking environment things like this into consideration certainly is paramount in what type of solution that you're looking for. Now, space allocation, again, a lot of what we just went through, you saw a lot of big examples, right? So your available footprint can play a significant role when identifying the solution in terms of both your flexibility and or your complexity, especially in environments when you have operators working right alongside the equipment. So in one example, maybe you have a very small aisleways. You can't necessarily take up a lot of space all of the time. You have to be flexible. So something like a mobile robotic platform with with a tug to drive the automation to its respected location, dock it and allow it to do work, and then take it from station to station in this manner. Maybe this is the way that you are able to bring the solution to your manufacturing environment. Or maybe you have the room available for some dedicated cells, and you can set it up so that your parts stay static, and you put the robotic solution on a 7th axis slide so that it can traverse from one end to the other. That way you don't have to worry about moving your engineering product. Let the automation do all of the motion and moving around. Or maybe you've got a much larger footprint and a need for not only AGVs bringing products to an automated station, but also some areas for staging as well as inspection. So you've got a little bit more liberty on your floor space. And again, obviously cost goes into this as well, but at least if you have the footprint or maybe you have a green field, you can definitely make use of the overall space and design it the way that you want versus trying to maybe shoehorn it into to a different area in terms of your space allocation. And then finally, a few other factors that might not, come to mind immediately are sometimes you have to play within the existing foundation. You have a certain quality, and you're not able to make any updates to the foundation. You have to deal with whatever the thickness of the concrete or reinforcements. Maybe you have crane and building height restrictions, or you can't use overhead cranes at all. So, or they're traversing over the top of your automation, so you have to be aware of what is coming in and going out of that environment. And then in some instances, you also have seismic conditions that you need to account for, depending on where in the world you are implementing this automation. Real quick case study here related to space allocation. This was a nacelle drilling and fastening station. So up to 2016, there were multiple stations that were needed in order to address this in a more of a manual process manner. And the challenge here was to condense it into one small footprint and make it a full one-up process where you're drilling and installing the fasteners and you're not taking any of the pieces apart to do any other kind of cleanup or inspection. And the team took on the challenge to create not only the automation to do that work, but also the material handling portion of it, orientation of the engineering in order to consolidate the footprint as much as possible, and saved a lot of floor space. And saved so much that shortly thereafter, they were asked to implement 2 additional systems in the exact same plant, because the manufacturer was in fact able to achieve a higher overall rate and meet a greater need by adding two additional systems into the plant. So again, they ended up eating up. In the end, they ended up probably consuming the same amount of space as all of the manual work, but the amount of rate that they were able to get was significantly higher than the overall manual process that they originally had. The next tier is scalability. Being able to understand what you need to do immediately and what you need to do for your overall long-term growth. Maybe you have an opportunity to set up a cell that has a little bit more floor space allocated to it. Doesn't necessarily look like you're taking all of the space when you first start using it, but then you have that flexibility to bring in some larger products or more diverse products, which again would improve your overall usage, percentage of use on your automation and improve the overall return on investment. Or maybe you have a mobile robot platform with a need for exchanging end effectors. So you use ATI coupling style technology in order to hand off different end effectors. That way the platform stays the same, but can be moved to different parts of the process and execute different style of work by doing that kind of a handoff. Maybe you have you're trying to allow for a fastener feed system that can send over a specific variety of fasteners, and then a year or two later the fasteners change, processes change, requirements change, but then being able to exchange only the cassettes would mean that you don't have to change anything from your overall floor space that you've taken up. You just have to improve the variety of the cassettes that you bring into the fastener feed station, which gives you an even more flexible, more variety, more of a mix of what this feed system can provide for you without having to change anything up. You just have to add an update to the equipment. Or maybe you have more of a large one-size-fits-all. I want to roll in a bunch of different types of parts, so I want maximum gantry reach and feasibility in order to not only process multiple pieces, but also multiple sizes of those pieces. So you give yourself a little bit more room. You fight for that floor space because again, you know that you're going to be able to bring in large and small elements and have the machine work on them all the same with with very few changes and certainly no change up to the footprint that you've already accounted for. Case study regarding scalability was back around 2016. Customer had come to us and they were in the process of doing fan cowl door assemblies. Now, originally, they had 2 technicians that would hold each end of the piece. You can see from the picture, it's a pretty heavy, curvature piece. So they would literally move the piece from one drilling location to the next by hand, because it's not a very heavy part. It's just a larger part, and they would do all of this working alongside the machine to do the fastener installation. What we ended up being able to do for them is provide the robot and the material handling element. So these various frames that could hold on to the different styles of the fan cowl, and essentially replacing 4 semi-automated cells with just one fully automated cell. And I guess the biggest selling point for this one was the return on investment was under a year. It originally had a 2-year estimate, and based on how quickly and how well everything went, it ended up showing its return on investment much sooner from an overall success story standpoint. And then finally, you get down to payload, reach, and accuracy. So again, from the earlier part of the presentation, this is kind of more of the real detail, the nuts and bolts of what goes into coming up with these types of solutions. So after you've kind of taken once you've identified all of the other items through application, through process, through space allocation, and the scalability that you're also trying to get to, now you actually get to start picking the specific pieces of the automation that are going to give you that best return on investment, right? So then you start taking things like, what is my payload? If I'm trying to move something, how heavy is that something? But more importantly, how heavy is the element that's also needed to move it around, and making sure that you pick. Sometimes a robot's not the right solution because whatever you're trying to move is too heavy for that consideration. So maybe it's more of a local gantry system versus an overhead crane, or an AGV if you want to be able to move it around on the floor instead of having elevated moves throughout your plant. The number of axes that you need in order to achieve your motion. Not everything is a robot. Not everything requires 6 axis of motion. Sometimes you can get away with a single motion application if it's as simple and repetitive. It's just cumbersome and fatigue related for someone else to do it by hand. So making sure that you kind of account for all of those number of axes of motion and really identify what you need. Reach. How big is the piece? Where does it need to go? How do I need to process it? And can I get to all of those areas? Can I get all of those areas from one location? Can I get to all of those areas, or do I have to move? Can I move from one side to the other? And what other pieces of equipment do I need in order to ensure that I get the same quality? If in fact I do have to move the engineering or move the automation to reach the full envelope of what's necessary. Accuracy and repeatability. These are huge in terms of what's needed for aircraft manufacturing. But sometimes you're just throwing bags of chips into a box. So your accuracy and your repeatability with vacuum cups doesn't necessarily have to be that great. So you get to that part where making sure that you apply the right amount and you don't go overkill and spend a little bit more money where it's maybe not necessary, just based on that. Speed and cycle time are always big considerations. The faster you can do any one of these operations, the better you have on not only product output but return on investment. And continued supplying to your customers in a reliable way. Mass inertia as well as IP rating. All of these things go into what kind of environment am I also going into? Is it wet? Is it dusty? Is it dirty? how well protected does this equipment need to be? That way it doesn't get contaminated as the first 3 times that I go to use it. So they're not always easy questions to answer, but if you really have spend the time and go through the exercise and map out as much of this as possible, you really will come up with the overall solution that you're looking for in the end. And lastly here, the various methods for robotic solution selection. So the first thing that you're going to come across is when you're looking into this nowadays, with the way that technology is and subject matter experts and the like, you've got online calculators. You've got a lot of different information available to you at your fingertips by doing your own research. And before, you'd have to go to the library and map out a lot of different things and make mistakes on calculations, and you weren't sure. Whereas now you've got checks and balances at the for online calculators. But again, you're still working at it on your own and kind of more in a vacuum. So when you get to that part, then you rely on internal technical teams to help guide the process as well, or application engineers, people that size these components every day of the week. So working in cooperation with them, they can certainly point you in the direction after you describe what your process is, and they can look at what you've come up with so far, and then direct you if that is in fact the most reliable or best fitting product, or if there's a recommendation for something different based on what they've seen and calculations they've run and similar instances in that respect. And then finally, you have collaborative partnerships with integration companies. This is the part where you don't have necessarily the full control anymore, because now you're relying on a third-party group to come in and work alongside of you. But keeping in mind that these are the companies that do this stuff all day long for multiple customers across multiple industries. They have a lot of different ideas. They've been able to work with customers to solve the same problem with multiple ways of a solution. There's an opportunity there to get more of that library of information without spending a lot of time having to do all of that research yourself. But again, now you do have to, it has to be a collaborative partnership. It has to be that vested interest in terms of what you need to get to that success, and working with and trusting their overall knowledge of the industry in order to get there in the first place. And obviously without that, without the trust, it's not going to be a very good relationship overall. But certainly one that has proven the test of time, up to this point. So, and that's all I got from the presentation side. So thank you very much for attending. And I think at this point I'll stop sharing, and then we'll take a quick peek to see if there are any questions that had come across while we were having this discussion. No questions. Well, that's okay. I talked enough. I talked for an hour. So, so I either lost everybody or.
Yeah, thank you for that, Austin. And this will be recorded as well, and we have all of your information. So if anybody live streaming this or watching the recording has questions, we can definitely get them to him after this. That's no problem, and I bet things will come in. I mean, there were so many case studies you touched on and so many different solutions that there was a lot of information, and it was all really good.
Thank you.
I just want to say, yeah, thank you so much for presenting. We really appreciated it. Like I said, this will be recorded on the website. Ascent Aerospace also has a membership minute video on our website that dives a little bit into their facility, and it's really cool. We interview some of their workers there. So if you have a moment, check that out on our website as well. Is there anything else that you'd like to finish on there, Justin, before we wrap up?
No, just thank you everybody for the time. Much appreciated for hanging out with me for the past hour to go through the presentation. And certainly if there's anything else that comes up afterward, we're immediately available to help out. So thank you again for the time and much appreciated.
Perfect. Yeah, thank you so much. We really enjoyed it. And everybody tuning in, be sure to tune in tomorrow as well. We have another episode of The New Normal with Tech Mahindra. They're going to be discussing work-safe digital return-to-work platform. So that's going to be 9 a.m. tomorrow. So thank you for joining us. And again, thanks, Justin. Everybody have a good day.